Good morning, ladies and gentlemen. Today we are on page 105 of your student journal, and our goal for the day is, today I will learn to represent, I spelled represent wrong, I apologize. Today I will learn to represent whole numbers as fractions. Okay, so our goal is today I will learn to represent, which represent means to show, whole numbers as fractions. So let's look at our vocabulary. Our first word is a whole, means an entire complete object or set. So 3 whole rectangles, and this is what the visual fraction model looks like, 3 whole rectangles. And then they show us as a fraction, 3 looks like 3 over 1. Because the 1 means the wholes were cut into one part, so this was only cut into one part, there's no parts, and I have 3 of them. And then they show this on a number line. So the number line goes to 3, but each whole part was only cut into 1. So that's why the denominator is a 1. Okay, so let's look at our steps. We're going to count the wholes, represent the numerator, number of wholes, and then represent the denominator, number of parts in each whole. Okay, so what does this look like? Here is my first problem, and it says 7 wholes. So they want me to do a visual fraction model for 7 wholes. So 7 wholes, I could do 1, 2, 3, 4, 5, 6, 7. That's what 7 wholes looks like. Now on a number line, 7 wholes would look like, I start my number line at 0, 1, 2, 3, 4, 5, 6, and 7. Now, the way that I could represent this as a fraction is 1 over 1, because my denominators are going to be 1 because each one has only one part to it. It wasn't divided into any parts, which means my denominators are all 1 here. So that would be 2 over 1, 3 over 1, 4 over 1, 5 over 1, 6 over 1, and 7 over 1. So 7 over 1 equals 7. And because the 1 means my wholes are partitioned only into one part. There's only one part in the whole, but I have 7 of them. So 7 over 1 equals 7. Okay, let's look at another one. This says 8 wholes. So this time I could maybe do circles. 1, 2, 3, 4, 5, 6, 7, 8. Okay, and on a number line, that would look like 0, 1, 2, 3, 4, 5, 6, 7, 8. And the way that I would represent each of those as fractions would be 1 over 1, 2 over 1, 3 over 1, 4 over 1, 5 over 1, 6 over 1, 7 over 1, and 8 over 1. And again, the denominator is going to be 1 because if I look at each whole one here, it was only divided or partitioned into one part. So 8 over 1 equals 8. They're the same thing. They're equivalent or equal. Okay, let's try some together. We're on page 106. And our first one says 5 wholes. So we need to draw 5 wholes. Maybe we could do rectangles. 1, 2, 3, 4, 5. So this is what 5 wholes looks like. On a number line, we can do 0, 1, 2, 3, 4, and 5. Now our denominator is going to be a 1. And the reason is because all of our wholes were only partitioned into one part. So here I have 1 out of 1, 2 out of 1, 3 out of 1, 4 out of 1, and 5 out of 1. So 5 over 1 equals 5, and I ran out of room, so I did it down here. So that is how I would represent that. They mean the same thing. Okay, for the 6 holes, why don't we do circles like I did on my second one? So 1, 2, 3, 4, 5, 6. And on a number line, that looks like 0, 1, 2, 3, 4, 5, 6. And the way I could write those fractions would be 1 over 1, 2 over 1, 3 over 1, 4 over 1, 5 over 1, and 6 over 1. So our answer would be 6 over 1 equals 6 holes. They mean the same thing. Okay, so ladies and gentlemen, you have the next 3 pages, actually I believe 4 pages to try on your own. Have a wonderful day.